a few of these. The first one is our constant function. We know that our constant function makes a horizontal line. And if we're listing the domain and the range, the domain is going to be from negative infinity to positive infinity. The range is going to go from, it's just actually going to be whatever the constant value is. So if it's f of x equals 2, then it's going to be 2 would be the range. Okay, our second one is just a linear function, which you've been doing that since Algebra 1 class, or maybe even pre-algebra. Its look is we're going from bottom left, upper right, kind of a diagonal line, going upwards towards the right. Domain's going to be negative infinity to positive infinity for both the domain and the range. Okay, the next one is one that you actually did graph, the absolute value function. It looks like a V shape. Domain, negative infinity to positive infinity. The range, we're starting at 0, so we're including 0, going all the way to positive infinity. Fourth one is called the reciprocal function. F of x equals 1 over x. The description that we use for that one to kind of help you remember it is wax on, wax off. So if you've seen the Karate Kid before, this, what is it, Mr. Miyagi teaches them wax on, wax off. So the domain is negative infinity to 0, and then 0 to positive infinity. So the y-axis is a boundary for the domain, and then for the range, the x-axis is a boundary. So it goes from negative infinity to 0, and then from 0 to positive infinity. The next one is our quadratic function, which again, that's one you should be pretty familiar with. That's just our parabola, U-shaped. It also is negative infinity to positive infinity for the domain, and then the range. The parent function is starting at 0 and going all the way to positive infinity. Next one is the cubic function. It's f of x equals x to the third. The sketch of that, we describe this as disco right. You've ever, I refer to it as the John Travolta. You've seen the John Travolta dance where he pointing up to the right and down to the left. I said that yesterday's class, and a lot of people said they didn't know who John Travolta was, so I'm starting to feel old. So disco right is our cubic. Next one's our greatest integer. Greatest integer is our stair stepper. So it's closed circle to open circle going left to right. Looks like stair steps. The one thing on the, and this was asked in the Zoom class, is how to write the range. We know the domain is negative infinity to positive infinity. But we say the range is all of our real integers. And so when we write that, we write it as I've written it here on the screen. Hopefully you can see that. It's kind of hard to see there, but we say for all y such that each element of y is all the integers, which the integer symbol is that z shape. It's a z with a double line, kind of diagonal line going down. That's kind of hard to see, so I wrote that there. Okay, our next one is the square root function. It's kind of a side stroke, so it starts at 0, 0 and goes up and to the right. It's a curve there. The square root function, the domain starts at 0 and goes to positive infinity. The range also starts at 0 and goes to positive infinity. The next one's our cubic root function. The description we use for that one is walk like an Egyptian. Starts down lower left, goes up, and then goes to the right. Domain's negative infinity to positive infinity. Range is also negative infinity to positive infinity. And then our last one that we're going to fill in today is our exponential. Our exponential, don't really have a description for it, but it starts in the second quadrant there. So negative infinity to positive infinity for the domain. And the range, the x-axis is a boundary, so it goes from 0 all the way to positive infinity, not including 0. As you can see, we have a couple more blanks. We're not gonna fill those in today, but eventually we will, as we get to those types of functions. So hopefully your graphs that are on your packet, hopefully your pictures are matching or look somewhat similar in terms of your parent functions. The next thing we're gonna do is we're gonna then talk now about our transformation rules. So this is where we're gonna kind of refer to our packets and just kind of see what we learned from our packets. So if we take a look, this first one is where we're adding or subtracting a constant value to our functions. So this would actually be page 2 and 3 in your charts. Did anybody notice on Roman numeral page 2, if you looked at your parent functions and looked at the changes as we added a number, what occurred to your graph? Somebody give us your conclusion that you noticed there on page 2. What did you notice?
The y-intercept becomes the value of c.
Okay, so if it was a plus, the curve moved up to the y coordinate or to the y-axis to that point. Let's just, so you can see, I know you've got your packets there, but I've got Desmos here called up. We can look at it. I'm just gonna use a parabola for this. So if I have my parabola and I add to that y equals x squared, and then let's just say plus 3. You can see that the parabola moves up the y-axis. So if we go to page 3, on those we were doing minus, so what then happened to the curve if it was a minus? Did everybody's graphs move down that amount also? So if I change it now instead of from plus 3 to minus 3, again, same curve, but we're moving down 3. Okay, so our first rule, our first transformation rule there is if it's a plus or minus after it's a vertical shift up or down by the C value. So we put that back up on the screen so you can fill that in. So plus or minus, the C moves it up or down depending on the sign there. Okay, for our next one, now we're talking about a plus or a minus inside the parentheses. So on your packets, this is on page 4. So you go to Roman numeral page 4. So when we look at the value inside the parentheses, anybody notice what now happens when we have a plus or a minus inside the parentheses? It's a horizontal shift. So we go back to Desmos just so we can take a look at what that looks like. So now instead of my, let's just get rid of this curve here. Now if we do, let's say y equals, we'll just use the one on your sheet there, y equals x plus 2 squared in the parentheses. Notice when it's plus 2, it shifts it to the left. And if it would have been minus 2, as you can probably guess, it's going to shift it to the right. So if we do x minus 2, when we square it. So again, here's the parent function. We go plus 2, it moves it left, that's the blue curve. If it's minus 2, it moves it to the right, horizontal shift. Okay, so let's go ahead and add that to our transformation. So horizontal shift. You know, one of the things I wrote in the chart there, I know it's, if you're looking at the actual equation or function itself, that's a little bit tricky because if it's plus, it's moving it left, and if it's minus, it's moving it right. If you think about setting the parentheses equal to 0, the x value is actually a negative c, so that moves it left. And so however you want to remember that, just like I say, understanding those rules is pretty important as you're going through that. Okay, just so we're staying in order on our sheet here, we're going to go to the next one, which actually takes us to not the very back page, but the page that is right in front of the very back page. So it should give you the graph of x squared, 2x squared, 5x squared, 10x squared all in one graph. Let's go back to Desmos here and we'll take a look. We've already got these type 10. We'll get rid of the 2 we just did. Alright, so if we put a 2 in front of our graph, notice what happens. No parentheses here, we're just putting 2 in front. Now I'm gonna put a 6 in front. As you can imagine, probably if I were to put a 10 in front, what's gonna happen to the curve? It's gonna continually, it's gonna vertically stretch more and more. Okay, so if there's a number in front that is bigger than 1, we know that it's a vertical stretch. Now, if I put a number in front that's less than 1 or bigger than 0, so I'm gonna put, let's say, 1/2 in front. Notice it kind of compresses my curve. I'll do 1/4 now. Again, it compresses it even more. So for a rule, when we have a value in front that's bigger than 1, we say that that is a vertical stretch. And if it's less than 1 or bigger than 0, we say it's a vertical compression. So it flattens the curve. Hopefully your curves look that way when you plotted those on your calculators. Okay, let's go ahead and go to the next one. The next one is when we make the function negative, we put a negative in front. This is going on your packets to page Roman numeral 6. Let's see how that affects our curve. And we go back to our original parent function with the parabola. So there's our parent function. If I put a negative in front, again, a negative without the parentheses, can somebody tell us what's gonna happen? You wanna try?
Oh, I just said it flips.
Yeah, it flips and it reflects over the
Exactly.
x-axis. So if I've got a negative, notice it creates that purple curve right there and reflects over the x-axis. Now, just so you can see it better, I'm gonna do the cubic curve for the negative inside the parentheses, because it's kinda hard to see with the parabola. So here's my parent function for a cubic. It's John Travolta, disco right. I put the negative inside the parentheses. Notice it's gonna now reflect over the y-axis. So the red curve becomes the blue curve. Let's put our sheets back up there so you can see that. So we've got reflection over the x-axis when it's negative in front, reflection over the y-axis when it's negative inside the parentheses. We have one more scenario that we're gonna discuss here on our transformation rules, and this would be what is on the back page of your packet. We've already talked about the vertical stretch and vertical compression. Now we're talking about when we put a number in front of the variable inside the parentheses. So we've changed the variable so it's not too confusing for you. The variable here is the letter B as opposed to the letter A. So we put a number in front. Let's go back to our Desmos. And we'll go back to the parabola. So here's my parent function of the parabola. If I put a number inside the parentheses that is bigger than one, so right now I'm gonna put a 2 inside the parentheses in front of the variable. Notice what happens. Now we describe this one as from the horizontal standpoint. So from a horizontal standpoint, it is a horizontal compression when the number is bigger than 1. And when the number is between 0 and 1, so this time I'm gonna put 1/2 in front, inside the parentheses. Notice that it gives me the outer red curve there, and it stretches it even more. Let's just do one more. I'll put, let's say 1/4 inside. If we sketch that, notice it stretches it horizontally even more. So let's move back to our sheet here to fill that in. So compression horizontally if the B value is bigger than 1. Horizontal stretch if the B value is between 0 and 1.